Actually, let me not share it. I'll just use this too first. Okay, so carbon compounds may you start off with what sort of compounds does carbon form?
Covalent.
Covalent compounds.
Covalent.
And what do you mean by covalent bonds? Like what happens in a covalent bond?
And formed by sharing
Pair
of
of
electrons.
electrons.
Between two atoms.
Yes, so electrons are shared between pair of atoms. The number of electrons that will be shared, two things you need to remember. One is that both the atoms share their electrons equally. So if it's a bond between carbon and oxygen, if carbon gives one electron, oxygen will give one electron. If carbon gives two electrons, oxygen will give two electrons. So the number of electrons that are shared are equal in both cases. And that number will depend on the atom getting 8 electrons in the outermost shell. Okay, so both of these ones, you like, if you follow this, you'll be able to figure out ki, okay, single bond hona chahiye ya double bond and all of that. Okay, follow that. We'll quickly revise covalent compounds ka thing. Now I'm not going to start simple. Can you guys draw the structure of, like, show me the electron, this thing, dot representation of ethane. Okay, so iske liye, first of all, what is the formula of ethane? Like, send it on chat. I need answers from all of you. Everyone send it on chat. The formula of ethane. Yes, Puneet, yes, Aditya got it. Elena, both the Adityas, good. Abhishek Trivedi, okay. Ananya, yes, absolutely. Anirban Vitta, yes. Neil, correct. Who's remaining? Aditya Mundra, have not received from you yet. Puneet sent. Snehal, you, I have not received from you also. बाकी सब लोग ने भेज दिया. Aditya, yes. So formula of ethane, all of you got it, is C2H6. अभी structure कैसे रहेगा?
All will be single bonds. T.
Okay. So all single bonds, oh, correct, because one hint is it's ethane saturated carbon compound है, सारे single bonds ही होना चाहिए. And the second thing is, okay, so all single bonds, मतलब how should I arrange?
So ma'am, C.
Yeah, carbon. So what is,
Carbon.
okay, carbon is attached to another carbon. So we've got our two carbons. Now how are the hydrogens attached?
Ma'am, hydrogen will be on like the first carbon. You will have 3 hydrogens over there, and there over on the other carbon you will have 3 hydrogens.
Yes. Okay. So like this you can figure out, like pehle structure you can figure it out like this, but the question asks dot representation. So dot representation matlab every electron is represented by one dot, or a cross you can use for clarity, but yeah, that's how it is. So iska dot representation, so yahan pe what does every single line mean? Like what does one line stand for?
Single bond.
That is a single bond, yes, but what do you mean by a single bond?
A pair of electrons is shared.
Yes.
2 electrons are shared.
Correct. Both of you are right. So one line means one pair of electrons. So 2 electrons are between carbon and hydrogen. So dot representation is going to look something like this. So between the 2 carbons, this single bond, sorry, H. And then each carbon is bonded to a hydrogen each, 3 hydrogens each with single bonds. This is what it looks like. And if you want to show the octet, you can see around this carbon, there's 1, 2, 3, 4, 5, 6, 7, 8 electrons. Around this carbon, 1, 2, 3, 4, 5, 6, 7, 8 electrons. So draw a circle around those 8 electrons to show octet. Then 2 electrons here, 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 2 electrons here. Yeah. So that's kind of how you show the dot representation. Okay. Then covalent bond. All right. Why does carbon do covalent bond only exclusively?
And due to catenation tetravalency.
No,
Because
tetra.
It cannot form cations and anions.
Yes. So Anirban, catenation and tetravalency, because of catenation tetravalency, it is able to form like a large number of compounds. But I asked, why is carbon forming only covalent bonds? So covalent bonds के through catenation होगा, उसके through, you know, like, okay, उसका valency 4 है because of electronic configuration. But tetravalent okay bhi, like something can have ionic bonds. So that was not my question. Okay. So why does carbon form only covalent bonds? Matlab, because it cannot form ionic bonds. Like it is not capable of forming cations or anions. All right, we have more people joining then. Vasudha, why does carbon not, like, why can't carbon form cations? Vasudha, hello. Oh, she sent it on chat. It takes a lot of energy to lose 4 electrons. Absolutely. And Abhishek Trivedi, why does carbon not form an anions?
Yeah, carbon does not form anions because it cannot handle more 8, like it cannot handle more electrons, so it forms covalent bond.
Okay, can you elaborate a little bit? Cannot handle matlab kya hoga? You're right, it cannot handle, but like handle is a very vague term, right? A little bit of extra explanation chahiye hoga. So you need to specify कि उसके nucleus में there are 6 protons, cannot hold on to 8 electrons in the outermost shell. So that's like 4 extra electrons. And the second thing is you can also talk about electron-electron repulsion. As you keep adding extra electrons, there's more negative charge in the valence shell. Yeah. So cannot handle is correct, but what can't handle? Little bit of elaboration. Yes, Vasudha and Ananya have sent it. So nucleus containing 6 protons cannot hold on to 10 electrons total. That is the problem that carbon has with anions. Okay. All right. So we established carbon forms covalent bonds only, and based on 4 electrons chahiye usko. So it's uska valency is 4. So it's tetravalent. And Anirban said it has properties of catenation and tetravalency, very flexible. Tetravalency matlab it can form 4 single bonds, it can form double bonds also, it can form triple bonds also. So very versatile, it can form so many different kinds of compounds. Now we used the word catenation here. Anirban, what do you mean by catenation?
And the self-linking property of carbon to form long straight bonds upon catenation.
Correct. So long, straight, or like long, branched, or ring structures. Okay. So absolutely. Self-linking is quite important. Through covalent bonds, quite important. Also forms like long chains, branch chains, or ring structures. Multiple ways of forming compounds. Okay, nice. So that is the reason, because it forms a large number of different compounds. It gets really difficult to study each of these if you take them one by one. So that is the reason we have slotted them into different types, different categories. Okay, so different categories. The main differentiation is saturated and unsaturated compounds. What do you mean by saturated hydrocarbons? What do you mean by unsaturated hydrocarbons?
Saturated hydrocarbons are
These
the
are only
ones with
single
single
bonds.
bonds, which are linked with single bonds, and unsaturated have double and triple bonds.
Absolutely. So if the compound contains only single bonds, then it's called a saturated organic compound or saturated hydrocarbon. And if it has at least one double bond or a triple bond, it'll come under unsaturated. Okay.
So alkanes are saturated and alkenes and alkynes are unsaturated.
Yes, that is what I was coming to next. Now, what are alkanes, alkenes, alkynes? Kahan se aaye? What do these words mean?
Alkanes are the first group. So they have only single bonds.
Alkanes have only single bonds, correct? Tanusha, can you tell me about alkenes?
Double bonds.
Yeah, if they contain at least one double bond, they come under alkenes. And alkynes, kaun batayega? Aditya?
They have at least one triple bond and follow the formula CnH2 and -2.
Yeah, so when you're defining alkynes, you can just say hydrocarbons that contain at least one triple bond. And yes, so that would be the general formula. Okay, so what alkanes, alkenes, alkynes, broadly we call them functional groups. So the defining factor ki double bond hai ya fir it has this sort of atoms. So all of that we call it a functional group. Now, what do you mean by a functional group?
It's atoms or group of atoms that replaces the hydrogen atoms in a hydrocarbon and help in deciding the properties of the carbon chain formed new one.
Correct. Yes, absolutely. A little bit of revise your phrasing there. Instead of saying help in deciding, they are responsible for physical and chemical properties of the compound. Okay, but idea is absolutely right. So functional group is, it can be either a single atom or it's a group of atoms which replaces any hydrogen in a hydrocarbon, and it is like those atoms or group of atoms are responsible for the characteristics, the physical and chemical properties of the compound. Okay, so some examples are like, again, you don't need to go deep into it, but examples are like alcohols are a functional group. So alcohols mein kya hai? Like OH, oxygen and hydrogen, oxygen attached to hydrogen. So this set replaces a hydrogen in an alkane, then it becomes an alcohol. Similarly, haloalkanes are another thing. So haloalkanes mein kya hota? Like one halogen atom replaces, where halogens matlab chlorine, bromine, iodine, fluorine also. So that's another example of functional groups. So there's like a ton of functional groups when it comes to organic chemistry. Okay. Now, if again, these atoms are called functional groups. Now, replacing a hydrogen atom with one of these, that is going to produce like a whole series of compounds. So that gives us homologous series. What do you mean by homologous series? How do you identify homologous series actually? Like
They differ.
yeah, go ahead.
They differ by CH2.
They differ by CH2 and what else?
They have same functional group and
yes, Puneet Neki said
similar chemical properties.
correct. Same functional group, matlab similar chemical properties, because that functional group is responsible for that. And every consecutive member, as Tanisha said, differs by a single CH2 group. Okay. All right. So these are like basics of your organic chemistry. If you study further, you'll come across all of these. और क्या है इस chapter में?
Miss, I had one doubt.
Yeah.
Miss, say if there's a compound with like one carbon in between, and it is single bondedly attached to 2 hydrogen atoms and 1 oxygen.
So we have a carbon, single bonded hydrogen,
and 1 double bond oxygen.
Okay.
So will this be a aldehyde or a ketone?
This is an aldehyde.
But oxygen is also there.
But hydrogen is also there, no? So aldehyde ka defining feature is C double bond O is there, and there's a hydrogen attached to the C double bond O.
So in ketone there will be no hydrogen.
No. So if you have C double bond O and there's carbon only on both sides and goes on, it can be anywhere, this will be a ketone, which is why the smallest ketone has 3 carbon atoms. Like smallest ketone is like the first ever ketone is propanol, because if you take away any one, you have to replace like bond fulfill karne ke liye, you need to add a hydrogen, and that makes it an aldehyde. So it's not a ketone anymore.
Okay, ma'am.
But you don't have functional groups, no? Like you just have to know what functional groups are. Or should we revise all the functional groups?
We don't have it.
They ask us sometimes, like not in detail, just what will the fourth member of this group be, or what will be the formula or something.
Oh, good point. IUPAC names and all. Okay, we'll revise that.
Yeah.
Yeah. Okay. So we'll start off with alkanes. Give me like the first 10 members, 1 to 10. Give me the name and the formula.
In chat?
नहीं एक करके अभी decide कर, like अभी I'll just call you guys out, क्योंकि इसके बाद alkanes के बाद we'll do alkenes also, we'll do alkynes also, so we'll cover everything. Alphabetical. Okay, Aditya Rane.
Yes, ma'am. First member will be methane.
Yes.
And formula is C1H4.
So do you write the one?
No, ma'am.
So just CH4.
Just CH4.
Okay. Next, Ananya. Second.
Ethane.
Ethane. And formula?
C2H6.
Okay. Next, Neil.
Ma'am, propane.
Propane. And formula?
And C3H8.
C3H8. Anirban, fourth member.
Butane, C4H10.
Yes, very good. C4H10. Abhishek, fifth one.
Pentane,
Yes,
C5H12.
correct. And Aditya Verlikar, sixth.
Hexane, C6H14.
Yes, C6H14. Aditya Mundra, seventh.
Heptane, C7H16.
Heptane, C7H16
16.
is correct. Yes. Next, Elena.
Octane.
Octane, yes.
C8H18.
Yes. Next, Amey, ninth. Amey Sonkhaskar, are you connected? Where are you? Amey is still not connected to the audio. Okay, Snehal, you go with number 9 then. Just the name and formula. Snehal Kashyap. 1 second. Okay. So we'll come back to you. Puneet,
Miss No Name,
no name. Yes.
C9H20.
C9H20. Snehal, can you tell this for number 10? Let me know whenever you're ready. Then we'll give you a chance. Okay. Tanusha, 10th member.
Decane,
Decane. Yes.
C10H22.
Snehal, decane. Decane. DEC. Deca. Okay. वहाँ पे T नहीं होगा. Then H
22.
22. Okay. All right. Now we'll go with alkenes. Neki, first member of alkenes.
Yes, ma'am. Methane.
Does methane exist? Okay, formula क्या होगा?
Wait. No, it's not possible. Ethane.
Yes. So first member of alkenes is ethene. Yes.
Yeah, C2H4.
Yes. And why is the first member ethene? Like, why should we have?
Because if there is only one C, how will we make double one?
Yes. So if this were presented to a question, how will you write the answer? Like, give reason why the first member of alkenes or alkynes is ethene or ethyne.
Because an alkene is not possible with only one carbon atom.
And why is it not possible? Like, that is the question indirectly asking.
Because it needs to form a double bond with another carbon atom.
Hydrogen can only form single bonds, so carbon
Yes.
needs another carbon atom to form double.
Correct. Neki, you had the right idea, but like if you were
To
talking,
put it into words properly. Yeah.
Yeah, you need to be able to present it as an answer. So yeah. So talk about double bonds. The first member, if with only a single carbon atom, that means that it has to bond only with hydrogens, which is not possible because hydrogen cannot form double bonds. So the first member has to be ethene with a minimum of 2 carbon atoms, so that there's no double or triple bond, depending on if you're talking about alkenes or alkynes. Okay. All right. Snehal, second member of alkenes. Look at your spelling, be careful. Propene, yes. And formula? No? Like, think about it. Double bond चाहिए ना? 2 क्यों आएगा? Secondly, like, prop मतलब कितने carbon atoms होना चाहिए? Snehal? तीन होना चाहिए ना? So C3 should be there. अभी hydrogens कितना होना चाहिए? So alkene, so 3 carbon मतलब 3 are bonded. Alkene है मतलब one of them is a double bond. So fill the rest with hydrogens. 1, 2, 3, 4. 1, 2, 3, 4. See how many hydrogens you will need. Formula आ जाएगा उससे. Beyond that, C3H6, few people have already answered. Snehal? So beyond that, हर एक का general formula है. So what is the general formula for alkanes? Cn
H2N.
2n plus 2. Alkenes?
CnH2n.
Yes. So alkenes में हमेशा it is twice the number of carbon atoms. So even if you figured out कि propene में 3 carbon होना चाहिए, you can directly figure out 2N matlab C3H6. Same with alkenes. Okay, so alkenes and alkynes may, whenever you're asked this sort of question, be a little careful that fifth member, if they've asked, don't think of C5 immediately, because C1 does not exist with alkenes alkynes. Fifth member matlab you need to do +1, like just cross check on your fingers. Okay, ethene, propene, butene, pentene, hexene. Okay. All right. So instead of going in an order for alkynes, I'll ask you guys random question. The first thing is, what is the general formula for alkynes?
CnH2n minus 2.
CnH2n minus 2.
2n minus 2. Okay. All right. First one. So, which is the Elena? Which is the seventh member of alkyne?
Octene.
Alkyne.
Octine, like the
INE, yes. Octine. So formula will be
C8H14.
yes. Or Neil, which is the third member of alkynes?
Ma'am, butane.
Butane, yes. Formula?
And it will be C4H6.
C4H6. Okay. Anirban,
Yes,
give
ma'am.
the name of an alkene that has, so give me the name and formula. Okay, first give me the name, then give me the formula. That has 4 carbon atoms.
Ma'am, butane and C4H6.
Alkene पूछा मैंने.
Okay, ma'am. Propene.
Tropine कहाँ से आया?
Ma'am, 4 carbon. Oh, sorry, ma'am. Butene.
Butene, yes.
C4H8.
C4H8, yes. Okay. Puneet, the rest of you guys can answer on chat, okay, in the meantime. So you guys also these questions. Puneet, so there is a hydrocarbon that has the form that has the formula. It has 3 carbon atoms and 4 hydrogens.
So it will be propine and it will be C3H4.
What homologous series does this come under?
Alkyne.
Alkyne. Okay. All right. So you should be able to identify alkanes, alkenes, alkynes, be able to differentiate between them and know the formula also. Like this, you guys should absolutely know: meth, eth, prop, but. Iske baad it's pent, hex, hept, oct, then no name, dec. The ends will differ for alkane, alkene, alkyne. That's also pretty obvious, pretty straightforward. यहाँ पे जो भी है, same thing gets affected. All right, some common functional groups, just identify the names. So the first one is alcohol. So alcohol is if there is like single bond OH, like An example is C2H5OH. So C2H6 is ethane. उसमें से एक हाइड्रोजन को निकाल दिया, so this has become C2H5. उसके प्लेस में put OH over here.
Ethanol.
इसका नाम है ethanol. Yes. You don't have functional group का naming and all, no? In case, yeah. Same pattern will follow. Eth for 2 carbon atoms. Just that क्योंकि alcohol है, तो end becomes OL. Then you have aldehyde. So aldehyde is when it ends in CHO. CHO मतलब C double bond OH. So ये है structure. Neki is asking, is alcohol a functional group or a homologous series? Alcohol is a homologous series, just like how you have alkanes, alkenes, alkynes. Alcohols is a series. So you have first member is CH3OH, second member is C2H5OH, and you have C3H7OH.
So alcohol, aldehyde, all these are homologous series?
Haan, homologous series defined by this functional group. So alcohol is also a functional group, or the group of atoms that makes it an alcohol is OH.
Okay, and we can't call them hydrocarbons because they also include O.
Yes, क्योंकि बस carbon, hydrogen नहीं, oxygen भी involved है, so they are not hydrocarbons anymore. Okay. Then you have aldehydes. For example, again C2H5 CHO. So this will be propanol. Aldehydes end in Al. Then you have ketones. Ketone is very similar to aldehyde except hydrogen nahi hona chahiye. You need to have carbon on both sides. Smallest ketone is this. Iska common name is acetone. This is your nail polish remover, by the way. So if any of you have used or seen nail polish removers, you've got acetone there. Iska proper IUPAC name, this name is propanol. Ends with one, ketone. Then you have carboxylic acid. This one of the carboxylic acid you guys are very, very, very familiar with. You worked with it so much.
Ethanoic acid.
Yes, OH. So CH3COOH. This you've known as acetic acid. That's the common name. But the actual formal name is ethanoic acid. Again, eth. And again, all of these are series. Like you have methanoic acid, that's your formic acid, and Stingwala acid. Then you have propanoic acid, butanoic acid, like you have a long list of them. Then what else? Then you have haloalkanes, haloarenes. Arenes nahi hai, but haloalkanes. Haloalkanes is where you have a halogen atom. Hamesha, usually convention is X represents halogen. So you have like CH3Cl. This is chloromethane. There can be more than one halogen atom also. So CHCl3, this is basically chloroform. CHCl3. So both of these are examples of haloalkanes where you have halogen atom replacing a hydrogen atom. Okay. So these are
Hello.
Hi. Hi. Yeah. Okay.
Miss, can you hear me now? Yeah.
Yeah.
Miss, I was asking like if Cl and Br both are in the same one, then
that's also
chlorine
a
and bromine both are there.
Yeah, absolutely. You have atoms like the so CFCs you must have read about when you're talking about ozone layer, pollution, greenhouse effect, and all. CFCs are chlorofluorocarbons. So those are organic compounds like carbon based compounds जिसमें fluorine भी है और chlorine भी है. Those are your CFCs. So absolutely you can have Cl and Br both attached to in the same this thing. That's also another type of haloalkane. Oh, maybe you got disconnected beach mein. So I was saying, yes,
Yeah, ma'am.
absolutely possible to have both different types of halogen atoms also in the same compound. So you must have come across CFCs, right? Chlorofluorocarbons. So that's an example where you
Okay.
have chlorine and fluorine in the same organic compound.
Okay, ma'am.
Okay, so iske alawa there's a ton of functional groups. Like if you happen to take chemistry bath mein 11th 12th mein you will also study about amines, which is a nitrogen based functional group. Ethers, that's also another functional group with alcohol in them. Lots of different functional groups, but these are some of the ones that's mentioned. These are like the most common ones that you see in everyday life also. So yeah. Iske baad you have isomerism. Isomerism may again you have the extreme basics. So one, you need to know what do you mean by isomerism. Iska definition kya hai? So what do you mean by isomerism?
Organic compounds with same molecular formula but different physical and chemical properties, different in structures.
Different structure, not physical chemical.
The compounds which have same molecular formula but different structural formula.
Yes. So same molecular formula, different structures. That's all matters for isomerism. Okay. So different chemical properties, physical properties, that again depends on the structure. हमेशा उतना different नहीं रहेगा. Like if you have two alkanes, all alkanes will react in a very similar way only. So don't bring properties into the picture. They may differ in physical properties, but chemical properties same हो सकता है क्योंकि same formula मतलब same atoms ही रहेंगे. Again, there's like different types of isomerism also. So all of that, don't get into it. Quite simply, same molecular formula. Same molecular formula matlab they have the same number of carbon atoms, same number of hydrogen atoms, and in case any other atoms are present, they have the same number and type of atoms, but different structures. How they are arranged, put together is different. So you can call them different structures, or you can call them different structural formula. Both mean the same thing, but yeah. How they are put together is different. So this is what matters, this is what is isomerism. And each of these different compounds formed from these different structures, they are called isomers. So abhi ke liye isomers, I think you'll have to be prepared with only butane ke isomers and pentane ke isomers. So butane ke kitne isomers hain? Two. Correct. Which are?
This one is straight and one is
Cyclobutane
branch.
and
Nahi, cyclobutane. Butane is different from cyclobutane. When you're talking about cyclic structures, uska molecular formula itself will be different. So
This butane and butane.
okay.
Butane nahi. So butane, you have N-butane.
And isobutane.
Yes. These are common names again, okay? So N-butane. So hamesha whenever you come across the prefix N, it stands for normal. So all the like 4 carbon atoms. So butane is C4H10. So all of them are in a single straight line. The rest of it filled up with hydrogens. And the second is isobutane. So whenever you come across iso, there's a T kind of a structure to it. So one becomes branched. So the remaining is all filled up with hydrogens. Let's write it down in case you're noting it down. Note down the hydrogens also. Okay. So similarly for pentane, you have 3 isomers. Pentane ka formula we've seen earlier, C5H12 hai, pent 5 carbon atoms. The first one is N-pentane. Just like N-butane, N means straight 1, 2, 3, 4, 5. And the rest is filled with hydrogen. 12 hydrogens here. Second, just like isobutane, you have isopentane. So iso matlab I said there's a T structure. So 4 of them will form the T. Pentane ka 5th one forms another chain. So basically iso ke liye, one of the corner ones, put it somewhere in the middle for one of these two. Pentane ke liye there's a third configuration possible. It's called neopentane. So whenever you come across neo, it means there's a plus kind of a structure going on. So there's a carbon surrounded on all sides with carbon. So this is what neo looks like. So just to make it slightly clear, difference between the structures, N is one straight line. Iso may you have a T kind of a structure. Here also you can see there's a T kind of a structure. And neo is if you have a plus kind of a structure.
Ma'am, but the chemical and physical properties will remain similar or same, right?
They won't remain the same for sure. Physical properties will change because the structure is different, their boiling point, melting point is going to be slightly different by 1-2 degrees. It's not like a very big change, but single digits maybe, but still it's going to be different. Chemical properties, again, it depends on what we're talking about. Like N-pentane, neopentane are going to be very, very different in terms of So N-pentane, neopentane will kind of be similar, but isopentane, because of this particular carbon, there's going to be a lot of difference in what kind of reactions it's going to undergo and all. So they will remain similar, but it's not the exact same. Not like they're going to become polar opposites also. In some cases, they do tend to. Again, it's hard to say that, Aditya, because it depends on what compound we are talking about and what configuration we are talking about. So some isomers will be similar to each other, but there'll be like one isomer which is very, very different. So that gets a little complicated. So we don't talk about chemical, physical properties so much. Physical properties, pakka, it's going to change for sure. No question about it. But chemical properties, you'll have to take it on a case by case basis. We can't say that for sure.
So the only constant similarity between the isomers is that formula.
Yes, same formula. Like the number of atoms, what atoms they're made up of is the same, but how differs. And frankly, the structures is what decides their chemical physical properties. So there's going to be a difference, but how different, similar, same, very different, we can't say that for sure. That's why when you talk about isomerism, just stick to this same molecular formula, different structures. That's it.
Miss, there was once a question like why can't ethane and others, that is propine, form isomers? So what will be the keywords used here?
So you talked about ethane and propine.
Like the eth and the pro, that the 3 2 carbon atoms and 3 carbon atoms, why can't they form isomers?
Oh, so that will have a very concept, like you just have to explain it in words that
So 3 can't form an isomer.
No,
because instead of a straight line, we can put one in a T formation, right?
Okay, so these are atoms. Okay, like Neki, the thing is, one thing you need to remember is that these atoms, like in the real world, they exist as 3D structures. And even when we say straight chain, it is not 100% straight chain. Like in reality, each bond exists, like it has a specific shape, like tetrahedral structure and all. Like it kind of exists this way, even if it's a straight chain. We call it a straight chain because beach mein branches nahi hai. Like when I'm starting from here, I can just go, like it's just a straightforward line I'm going without any going back and branches and things like that, intersections and things like that. So that's why we call it a straight chain. So you have to go by that, not directly what you see on paper. So this structure are the exact same, because what you do going from the first carbon to the last carbon is you're just like going in one single straight line without any intersections as such.
Okay.
Okay. Now, Puneet, coming to your answer, when we have 2 or 3 carbon atoms, because there's like extremely low number of carbon atoms, they don't exist different configurations to have multiple structures. Like if there's just 2 carbon atoms, that's it. How else are you going to arrange both of these?
So only one arrangement is possible.
Yes.
Okay.
Of the number of carbons, it just so happens that there's only a single arrangement or a single structure is possible, so they don't have isomers. Yeah.
Okay, ma'am.
Okay. All right. Guys, any other doubts, any other questions based on isomerism?
Ma'am, I actually have a doubt, but it's not on isomerism. I think it's on like the whole chapter. So can I just put it in the chat?
Yeah, absolutely. Or you can just say it if. I think we're pretty much done with the chapter now. Huh.
Yeah, ma'am. So the question was like, write the structural formula of an organic compound in which a heteroatom is present. So, ma'am, do we just write any functional group, or is there like a proper like a formula or something?
No. So they have like the question is very, very vague. It's asking about organic compound. So compulsory carbon needs to be there. Matlab, साथ में hydrogen also is usually there. And apart from this, they want a heteroatom to be present. So either you can choose the heteroatom to be a halogen, chlorine. तीनों के साथ you can figure out any carbon compound. It can be something CH3Cl, or you can make it a little complicated like C2H5 Br, something like, or chlorine if you are continuing, then it'll be this. Or instead of chlorine, you can think of alcohol, C2H5OH, CH3OH, single carbon atom के साथ, like all of these
Okay, ma'am.
per criteria. Organic compounds है, heteroatom है. So
Okay, ma'am. Thank you.
all right. Guys, any other questions? Like it can be from your mock paper, any other practice paper that you're doing, school workbook, question bank, कोई भी हो सकता है. Anything else you guys want to discuss?
Ma'am, I had questions
From
about.
fifth chapter.
I had questions about like some of the naming things like but1ene and all of that. The numbers in between the
Okay.
words.
IUPAC naming. ठीक है.
Yeah.
IUPAC naming is pretty simple. One is you need to know your prefix. So prefix is based on the number of carbon atoms. Do you guys get branch chains naming के लिए? Like something of this sort?
Miss, actually nomenclature is not there for us.
Pura. Like I know functional group is not there, but even alkanes.
Nomenclature is not there, I guess. The whole thing.
Nomenclature is not there.
But sometimes they have asked. I mean,
Yeah, they have asked, but not like this type of where we have to like the third one is branched.
Okay, that's what I was asking. Like not to this level, right?
Yeah, like this is Pro 5 in something, right?
Like that.
Pro 3 in, sorry.
Pro 3 in doesn't make sense.
Pen 3 in, I think.
Okay.
5 and third branch.
But okay, so you don't have like alkyl groups in the branches. Maybe you'll have double or triple bonds जिसका position numbers चाहिए होगा, something of that sort. Okay, I'll go over the very basics of it. We'll not do branch chain right now. First, prefix जाना चाहिए that you'll get based on the number of carbon atoms. This is your meth, eth, prop, all of that stuff. Then you need to know your suffix. Suffix is basically like think of it as a family name. So this will depend on abhi ke liye what bonds are there. So is it an alkane, alkene, or alkyne? Depending on what it is, it will end with ane, ene, or an. I. Now, alkanes pretty straightforward as long as it's a straight chain. For alkenes, alkynes, there's a special thing. You need to look at the position number of the bond. Double bond or triple bond. Okay. So the whole purpose of naming is you should be able to figure out what we are talking about without having to draw the structure of the compound. Okay. So simple ones ke liye, it's pretty easy. Like if I say ethane, you know what I'm talking about. It is C2H6. Eth matlab 2 carbon atoms. Ane matlab sare single bonds. So it happens to be C2H6. Now, what if I was talking about butene? So what information do you get out of this name butene?
4 carbon and it is alkene group.
Yes. But matlab your prefix gives you the number of carbon atoms. So but tells me there's 4 carbon atoms. Ene tells me that there is a double bond here. The rest of it is all like hydrogens. Okay. Let's not fill hydrogens again. Now, ene tells me that there is a double bond here. But where is the double bond? Is it over here? Or is it over here? Or is it over here? Position 1, position 2, or position 3? Kahan pe hai? Okay. So that's where your position number comes into picture. So if I write but, so there's but1 ene. This 1 tells me that 1 ene hai. So this tells me that the ene double bond is in the first position, like it's bonded to the, like double bond is there with the first carbon itself. So iska structure hoga C double bond C and then 4 carbon atoms. Then I can fill up the hydrogens accordingly. And if I have but 2-ene, because there is 2 in front of the ene, tells me that ene, matlab the double bond is present on the second carbon. So first carbon, second carbon pair is a double bond, then third, then fourth. Then I can fill up the hydrogens accordingly. Okay. So but 1-ene mein, you can see the double bond is over here. But 2-ene mein, the double bond is over here. So that's how you got to treat the position numbers. So I'll take another example. Let's do it with alkynes. Suppose pent 2-ine. How would the structure be iska?
Five carbon with the second one being a triple bond.
Yes. Second yahan pe there's a triple bond here. And the rest of it has to be filled up by hydrogens. Okay, guys, getting the hang of it? Numbers, Aditya?
Yes.
Okay, so it just tells you where this is there. Now, my question to you, does but 3-ine exist or but 3-ene exist? Is this a valid compound?
Miss, will it be just butene only?
Okay. Who else? Anybody else answering? But 3-ene, does this exist?
No, ma'am.
Why not, Aditya?
Ma'am, because then it will be but 1-ene. Because
Yes.
we count from one direction.
Correct. So but 3-ene is not a valid compound. So even if I attempt to do this, so you might think 1, 2, 3, third carbon pe hai. But again, come back to the point that these molecules exist in 3D structures. They are not what we draw on like paper. Like kyunki we don't have anything else to draw on, we do it on paper. But these are 3D structures. This is basically the same as if I look at it from this side. Yeah, if I look at it from this side, I have carbon, 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 and like first carbon pe hi double bond hai na. So this is the same as but 1-ene. So that's another rule. Whenever you're deciding the position number, right? If there are multiple ways of counting, like if I can count from the left side as 1, 2, 3, 4, or if I can count from the right side as 1, 2, 3, 4, go with the smaller number. So position number always has to be the smallest number. Okay, so I'll give you guys one more. What is the name of this compound? Elena got it immediately. Very good. Neki, yes. Add the hyphens between the number and the words, okay? Aditya got it. Aditya Rane and Aditya Velekar, both of you got it. Puneet, yes. Right. Ananya, Anirban, Neil, Abhishek, Aditya Mundra, Snehal. Anirban, you are partly correct, but what is the position number of the double bond? अभी तक वही discuss कर रहे थे ना? How will you represent that? Neil, Neil and Ananya, that is like I just discussed. Don't just blindly start from left to right. If there are multiple possibilities, always give it the smallest number. So either I can start from here, in which case pent 3 in hoga, or I can start from here, 1, 2, in which case it will be pent 2 in. So always go with the smallest number. Pentene, you guys got it. 5 carbon atom here, there's a double bond here. But where is the ene? It is not like, if you need to specify where the position of this is, always give it the smallest number. Always look for the different possibilities. अगर यहाँ से चालू किया तो it's on the 3rd carbon पे आ रहा है double bond. But if I start from this side, it's on the 2nd carbon, the double bond. So this will be pent 2E. Okay. Guys? Neil? Anarpa?
Miss, but what about pen 3 will it make a compound similar to this one?
No. So pent 3 doesn't exist. क्योंकि even if you try to figure out pent 3 वो तो automatically pent 2 ही बन गया ना. So that's not like a valid name. So this is another type of isomerism. So like you can see both of them molecular formula is C4H8, but structurally they're differing like where the double bond is. So that's another form of isomerism. Okay. Okay. Any other questions on carbon compounds?
They don't really ask questions about allotropes, right? Like what type of questions in this?
Allotropes, no, like just know the differences between diamond and graphite. उससे ज़्यादा नहीं होगा. But yeah, like historically, if there's a question from carbon compounds, I'd much rather focus on the rest of the chapter because you'll get to use all of this further also. These are like fundamentals, basics.
Miss, can they ask to like draw the structure of graphite or diamond?
No. Even if you have to draw it, it's very simple. Like graphite ke liye, just draw hexagons. Graphite, draw like hexagon. यहाँ पे एक और hexagon. 1, 2, 3, 4, 5, 6. This should be enough. Add one more maybe. And same thing upar bhi, like another layer of hexagons. And then draw dotted lines in between. This is what graphite is, right? Like it's made up of layers, hexagonal layers, and the electrons are moving in between. And for diamond, again, carbon forms 4 bonds and all 4 of them are fulfilled. So it needs to be tetrahedral shape. So that's basically like if you take a point, draw one upper, then draw 3 more as well. Like think of it as a fan structure. Then again from this point you have 1, 2, 3, 4, then 1, 2, 3, 4. So you just have to, like, every point of intersection, there needs to be like 4 lines coming from that. Think of it that way. You can connect these also. Three, 4. Then यहाँ पे already 2 are there at this point, so you just need 3, 4. यहाँ पे you can do 1, 2, 3, 4. So it just needs to be a network, like where every point, think of it, it's basically a carbon atom, so 4 of them should come up there. Okay. Ananya is asking, can the structure for cyclohexane come? Cyclo compounds are just like, again, like, it's just carbon atoms where, like, cyclohexane is just a hexagon. Cyclo means it's a closed structure, like it basically forms a polygon. It's not like an open structure. So if you get cyclobutane, so butane matlab 4 carbon atoms hona chahiye, and cyclo means all 4 of them, like, you should have a closed structure. So what is a closed shape you can form with 4 points? Just a rectangle, closed shape with 4 points. So cyclopropane matlab triangle hoga. That way you don't have to worry too much. So if you see cyclo something, then it's basically a closed shape. Cyclo is ring structure. Okay. All right. Anirban, you said you have one doubt. What's up?
Yes, ma'am. Now my question is, why a covalent bonds are bad conductor and have low melting and boiling points?
Can you repeat that? What? Why?
Yes, ma'am. Ma'am, why a covalent compounds are bad conductor and have low melting and boiling points?
Oh, very nice. Okay. So covalent compounds, okay, properties of
They are bad conductors because they don't form ions.
Again, so what is the fundamental difference between ionic compounds and covalent compounds?
They form
Ionic
ions and
compound
they don't
transfer of
form
electron takes place and covalent sharing of electrons takes place.
Correct. So Neki, you said they don't form ions, right? Again, elaborate a little bit on that. Like, what makes ions different from whatever covalent compounds have? So they're bad conductors because there's no free electrons and there's no charges also. Ions may you have positive charge, negative charge. So if you apply like a potential difference, those charges can move, and that's what electricity is. That's how they conduct electricity. Covalent compound may the electrons are shared between the bonds, so there's no free electrons, and they don't form ions. Matlab, there are no free charges also that can conduct electricity. So these are the terms that you need to use, why they are bad conductors of electricity. And why do they have low melting and boiling points? Again, covalent compounds, they form molecules. And each of these molecules is free and independent. Like, these molecules
They
are
are bonded by weak forces of attraction.
Yes, they have weak intermolecular force of attraction that can be broken easily. That's why they have low melting and boiling points. Okay. All right. Anything else from this chapter, guys? Okay, I am taking it as a no. So we'll go on to periodic classification now. Okay, so periodic classification main things you need to know are the different theories. So starting with history mein, Dobriner's triads. What did Dobriner say? What was his theory in classification? कौन बताएगा? नील?
Can
Yeah, go ahead, Anand.
Brian tried to arrange the elements with similar properties into groups. He identified like some groups having 3 elements each, so he called those 3 elements as triads. And he showed that the 3 elements in a triad were written in the order for increasing atomic masses, and the 3 elements in the middle element, which was there, was roughly the average of the atomic masses of combining of both the other 2 elements.
Yeah, pretty much correct. So absolutely right. You touched on all the points. So he grouped elements with similar properties. He found that these groups contained triad of elements, like 3 elements in a single group. And when he arranged them in increasing order of atomic masses, the mass of the middle element was equal to the average of the atomic masses of the other 2 elements. Absolutely. Anirban, I think you started putting it in the chat. They arranged in group of 3 elements having similar properties, correct? But yeah, so the increasing order of atomic mass and average is the main part. Like that was Dobriner's contribution to it. Okay. And can you guys tell me a couple of examples of Dobriner's triads? Think of 2 examples.
Lithium, sodium, potassium.
Okay.
Lithium, calcium.
Magnesium, calcium,
Chlorine, bromine. Lithium, sodium, potassium.
Lithium, sodium, potassium is one. The second one, Anirban, which one were you talking about?
So that was calcium, strontium, and barium.
Calcium, strontium, barium. Second. And for safe side, have a third one also in mind. Chlorine, bromine, iodine, absolutely fits. Okay. Why did Dobriner's triads fail? Drawbacks?
It could form only a limited number of triads.
Correct. Yes. And the second point, all elements could not be fit into such triad. Like only a limited number of them fit that. Okay. Then after Dobriner's triads came Newland's law of octaves. What is the Newland's law of octaves?
Every 8th element had similar properties to the first one.
And how do you decide which is the first, which is the 8th? That's an important factor there, Nikki.
According to the atomic mass.
Correct. So when
first it was mass. In the new table, it's atomic number.
Yes. Stick to mass for everything except for the modern periodic law. Okay. Yeah. So Newland start off with when Newland arranged the known elements of his time in the increasing order of atomic mass, and the 8th element had the same physical and chemical properties as the first element, just like the notes in a musical what do you call it, octet. Drawbacks, why did his law fail?
It only was applicable till calcium. It didn't work for the heavier elements.
Absolutely. Awesome. Okay, then came after Newland, we have Mendeleev's periodic table. Mendeleev was, is an important thing. Okay, so first, what is Mendeleev's periodic law?
Ma'am, Mendeleev periodic table states that the properties of the element are the periodic functions of the atomic masses.
Absolutely. One small correction, his table does not state that, his law states that, okay, according to Mendeleev's periodic law. Second, what are the advantages of Mendeleev's periodic table, which was absent like till then at that time in classification?
Ma'am, Mendeleev left some gaps in his periodic table for the elements yet to be discovered. Ma'am, the second was the Mendeleev's periodic table could accommodate noble gases when they were discovered.
Without disturbing the rest of the table. Okay, so like mention that point also. Very nice. Now speaking of the elements that he predicted, he also predicted their properties also accurately, what their atomic mass would be like and how they'll react with other elements and all that. Can you give a few examples of those elements that he predicted that were discovered much later?
There was Ika boron, which was, I think, scandium. Ika aluminium, which was gallium, and Ika silicon, which was germanium. So he predicted the properties.
Very nice, correct. So you have Eka boron, like remember the names that Mendeleev had given and also their current names. Okay, just know which those elements are. You have Eka boron, Eka aluminium, and Eka silicon. So boron, similar to boron, is scandium. Similar to aluminium, Eka aluminium is gallium, and Eka silicon, similar to silicon, is germanium. Also, why did he give the names Eka boron, Eka aluminium, Eka silicon?
So Eka aluminium means the new element will have properties like aluminium.
Correct. So Eka boron, Eka aluminium, Eka silicon means it has, that particular element has properties similar to those of boron, aluminium, silicon. So Eka, like in his language, is kind of like one. So he called it, basically you have boron and you have boron 1. That's similar to boron. That's the idea behind it. But yeah, so if you're asked this question, just mention that they have properties similar to those particular elements, which is why he called them that name. Okay, and now drawbacks of Mendeleev's periodic table. 3 major, like tell me any 3 major drawbacks.
He could not give a correct or specific position to hydrogen.
Hydrogen was a big anomaly. Okay, and what was the like what was the problem with hydrogen? Why correct position? Matlab, what are the possibilities there?
Because it could even come along with noble gases.
No, hydrogen we're talking about.
No.
What is hydrogen similar to? Which are the 2 groups of elements hydrogen is similar to?
Ma'am, alkali metals and halogen.
Yes. So hydrogen could be placed with either alkali metals, and give a couple of reasoning for that. Like why do you think it should be placed with alkali metals and why do you think it should be placed with halogens? So you have similarity with alkali.
Both have a valency of 1.
+1. It has a tendency to lose the electron, and the kind of compounds it forms with oxygen and halogens similar to alkali metal. And the similarity with halogens,
You can have a valency of 1, -1.
more than that, mention the fact that hydrogen is a non-metal. That's like the most obvious thing that makes it different from alkali metal but more similar to halogens, right? It's a non-metal, and in the elemental state, it exists as a diatomic gas. Like hydrogen exists as H2, which is similar to halogens that exist as Cl2, F2, Br2, that way. Okay. And then you can mention valency rather than +1. Hydrides are very, very rare. It forms covalent compounds, just like halogens, because it's a non-metal. Okay, so position of hydrogen was an anomaly. What are like other two drawbacks for Mendeleev's periodic table?
Ma'am, isotopes pose the problem
Yes,
because like it has same atomic number but different atomic mass.
correct. Very nice. So Mendeleev's whole deal was based on, or Mendeleev's periodic table was based on atomic mass. And when he came across isotopes, again, because of their differing atomic masses, yeah, he didn't, one could question, where to place a particular element, where to place the isotopes of that element. And the third anomaly, like third drawback,
Ma'am, I think like I'm not sure, but I think like some the increase of atomic mass was not constant. Like some lighter elements were placed after the heavier elements.
correct. So Mendeleev did not follow his own rule where he placed elements in the reverse, like, yeah, lighter element placed after the heavier element, because he gave more priority to the similar physical and chemical properties. These are the drawbacks. All right. Now coming to modern periodic table, like this solved a lot of issues that Mendeleev had with this periodic table because of one fundamental difference that modern periodic law followed. So what is the modern periodic law and how is it different from Mendeleev's periodic law?
Also, ma'am, like the modern periodic law states that properties of an element are the periodic functions of the atomic number
Correct.
instead of atomic mass.
There you go. That's the difference with Mendeleev's law. So modern periodic law based itself on atomic numbers, which solved a lot of problems that Mendeleev had. So isotopes ka issue solve ho gaya. And the other anomaly, which is heavier elements, lighter elements, like that also got sorted. Okay. All right. Now, history, like what you have to know is what the periodic law is and what are the drawbacks. Now, once we come to modern periodic table, you guys need to know the trends in the different properties. Like one, what the different properties are, and two, what are their trends. Matlab, when you go top to bottom in a group, what happens? When you go left to right in a period, what happens? And there's a lot of application based questions also on these trends. So it's not as straightforward as, oh, increases, decreases. You'll be given like a specific set of elements, or maybe a group of elements. One is in the second period, one is in the fifth period. So you need to compare size kaise rahega, metallic nature kaise rahega, and all of these other things. Okay. So we'll get onto it. So first we'll discuss the trends. Uske baad we'll look at some like application based questions or anything. Okay. All right. So Ananya, what happens to atomic size? Like, let me write this down. Yes. Okay, first one, atomic size. As you go top to bottom in a group, others, rest of you guys send it over chat.
The atomic size will increase as we go from down.
Yes. And left to right in a period?
It will decrease.
Yes. Left to decreases. Yes. What is the reason for this trend? Who? Anirban. Like, why does it increase in a group? Why does it decrease in a period? Anirban?
Because they're vertically arranged in group and horizontal in period.
No. Vertically or horizontally? Like, first, let's focus on a group. So when you go top to bottom in a group, atomic size increase हो रहा है. क्यों हो रहा है?
Because number of shells decreases, that's why.
Number of shells decreases or increases?
Some increases.
Increases. Think of lithium, sodium, potassium. Lithium is just 2, 1. Sodium is 2, 8, 1. Like extra 3 shells hai na isme. And potassium is 2, 8, 8, 1. 4 shells hai isme. So that is why it increases. So Aditya, Rane, Ananya also have mentioned increases because of more shells. New shells are added when you go down a group. So that's why the atomic size increases. Okay. Left to right in a period, it decreases. So Abhishek, why does the atomic size decrease?
Because effective nucleus charge increases, so it pulls the electrons closer.
Correct. So left to right in a period. So think of left to right kya hai? Lithium, beryllium, boron, carbon, nitrogen. So left to right as you go, atomic number increases. Matlab, the effective nuclear charge is nuclear charge matlab it's only because of protons. Number of protons is increasing, nuclear charge increases. So the pull on the electrons also increases. Okay, so the force between Aditya Rane sent force between electrons and protons increases. Absolutely. Ananya said increase in nuclear charge, which pulls the electrons closer and reduces the size of an atom. Absolutely. Okay. Okay. और क्या properties है atomic size? Then metallic character. Top to bottom group में क्या होगा? Aditya Mundra. Aditya, you there? Right. Nikki, what about you? What happens to metallic character as you go from top to bottom in a group?
It increases.
Increases is absolutely right. And left to right, क्या हो रहा है? Elena?
It decreases.
Decreases is absolutely right. So metals, when you go up towards the right, see that there's a lot of non-metals on the side. Okay. So top to bottom it increases because the power or the tendency to give away electron increases. So that's what defines your metallic nature. What other properties do you guys have? Ionization energy or सब है क्या? Atomic size, metallic, non-metallic. Electron affinity and ionization energy. Should we discuss that? Alright, electron affinity क्या होगा top to bottom in a group? Right, come on guys, what happens to the electron affinity as you go from top to bottom?
Remains the same, right? In the top to bottom.
No. So electron affinity, like think of it. Electron affinity is affinity to electrons, like likability to electrons. So top to bottom, it decreases. So electron affinity is reverse of what happens to the size. Like as the size increases, the nucleus can't hold on to the electrons as easily, right? So electron affinity decreases top to bottom. So what will happen in a period left to right?
Increases.
Increases. Electron affinity increases left to right in the period. Okay. Then ionization energy. So ionization energy, think of how easily you can remove an electron. So top to bottom, the ease of removing an electron, does it increase or decrease?
Increase.
The ease of removing an electron increases. So the ionization energy, the ease of removing electron increases. So the energy that you need to spend, like how much effort you need to put in to remove that electron, will then increase or decrease?
Ma'am, it will decrease.
It will decrease. And across a period, what will happen? The ionization energy, like how easily can you ionize it? How much energy do you need to put in to remove an electron? Increase. This will increase, yes. The alkali metals, you can remove it quite easily. You don't have to spend a lot of energy. But halogens, they already have 7 electrons. It's going to be very difficult to remove an electron from there. Okay. And finally, last two properties, electropositivity. Positivity. So electropositivity is, think of it as metallic nature. Like how easily can the atom lose electron? So top to bottom in a group, electropositivity decreases or increases?
Increases.
Ma'am, it increases.
Increases, yes. And in across a period?
Decreases.
Decreases, yes. And electronegativity is the opposite of electropositivity. So electronegativity is how easily can it attract electrons. So top to bottom, electronegativity will increase or decrease?
Decrease.
Decrease.
Yes.
Decrease.
And across a period?
It will increase.
Increase, yes. So remember, so top, like if this was my periodic table, top to bottom, electronegativity decreases. So somewhere on the top is like the higher electronegative, and across a period it increases. So this corner, whatever element is there, is the most electronegative. So this corner, what element is there is fluorine. So fluorine is the universally the most electronegative element in the whole periodic table. Fluorine is most electronegative. Yeah. All right. What else? Metallic nature. Okay, all of these we have covered. Right, let me open up periodic table. Asha, before this, do you guys have any questions? Somebody was mentioning like ye wale chapter mein you had a lot of questions. You wanna shoot those?
I sometimes have doubts when they ask us to name the period number and group number of a particular X element or Y element.
Okay. Okay. Right. You guys able to see the periodic table, or should let's get a bigger one? Okay. So group number, period number, let's see if we can figure out a formula for this. Aasan ho jayega. Period number is pretty easy. So which period it is in is directly equal to the number of shells. Okay, like for example, if we have potassium, इसका electronic configuration है 2881. तो कितने shells है potassium में?
4 shells.
Four shells, right? So which period it's in is very direct.
Fourth period.
So we can see here 1, 2, 3, 4. यहाँ पे है potassium. Okay. Now coming to the group. Group में there are two cases. So group में now this will depend on the number of valence electrons. So if it is 1 or 2, it's pretty direct. That is equal to which group it's in. Like potassium has 1 electron valence shell, वो है first group में. Same with 2 electrons, you have beryllium, magnesium, calcium, all of these second group में. Anything greater than that, if you have to figure out which group it's in, you need to do plus 10. Plus 10 will give you the group. So like aluminium, so aluminium is 283. 3 electrons hai, so 3 plus 10, 13th group mein hai aluminium. I'm guessing you'll be asked these questions only till 20, so that's a very foolproof way it's going to work. For example, if you have to figure out silicon, can you tell me which group silicon is in? I'm gonna stop sharing. Yeah, predict which group silicon is in, then I'll project the periodic table and we'll see if you guys got it correct or not. Send it on chat. Yes, Elena got it.
Ma'am, can you repeat the question?
So tell me which group silicon is in. The group number which silicon is in. Anirban got it. Very good. Ananya got it. Abhishek Trivedi, yes. Neil got it. Aditya, yes. So this works only till 20, huh? Just be careful. Because 21 ke baad the T block comes into the picture, it'll be difficult to use that. But yeah, till 20, this is a foolproof way you can get it. Can you tell me which period silicon is in? Group number, pata? Kariya. Which period is it in? Yes, Aditya, that was fast. Abhishek, Anirban, Elena, good. Yes. Nice. You guys got the hang of it. You guys got it right. So group number is silicon 4 electrons hai. So 10 plus 4, 14. 14th यहाँ पे है silicon. Group period is number of shells 284, 3 shells. Third period silicon. Yes, all of you got it. Nice. Good stuff. So once you figure out which group, which period it is in, can you figure out what would be the valency? So silicon, you figured out it's in the 14th group and third period.
Valency, though, if we know the atomic number, then automatically we'll get it.
Good. Can you tell me what will be the formula of the compound that silicon forms with oxygen? Nice. Anirban is the first one to get it this time. Good. Elena, absolutely. Good. Abhishek Trivedi got it. Ananya got it. So once you know the valency, either from group number or from the electronic configuration. So silicon ka valency is 4, oxygen ka valency is 2. Easily figure it out. Crisscross. Yes, Neil got it. Again, another thing is like silicon is where very similar to carbon, no? So carbon, what compound it forms with oxygen? Silicon is also going to do the same thing. That's going to be SiO2. Aditya, yes. Okay. All right. Here's another type of question. Okay. I'll stop the periodic table. So an element X. So element X is found in the periodic table in group 16 and second period. So what can you say about is electronegativity? Like, is it going to be, is it an electronegative element or will it be electropositive? Another way of asking is like, do you think it's a metal or is it a non-metal?
Non-metal.
Elena got it. So answer in terms of, would you find it electronegative or electropositive? Neil, yes. Abhishek, yes. All of these are like really long words, so forget your typing. Anirban, yes. Nikki, yes. So second part to this question, that this again like two subparts. What type of a compound will it form with one with magnesium, and what type of a compound will it form with nitrogen? Anirban, no, group 16 second period. So magnesium का वो formula गलत है. Check again. And second, when asked what type of compound, answer with ionic or covalent. So magnesium के साथ किस तरह का compound है? Is it going to be ionic or a covalent compound? And nitrogen के साथ, is it going to be an ionic or covalent compound? Abhishek is the first one this time. Good. Elena also sent. Yes. So all of you got it, right? So this is an electronegative thing. So Nikki has said electronegative matlab it's going to be predominantly a non-metal. Predominantly, this is a non-metal. So magnesium is metal. So metal or non-metal के बीच में किस तरह का compound होगा? And nitrogen is again a non-metal. Yeah. So non-metal के बीच में किस तरह का compound होगा? Covalent. Okay. So that's how you have to answer. Like that's the route that you need to figure out. Okay. So what would be the formula of the compound with magnesium फिर? Coming back to our valency. Ananya figured out concept compound here. But again, Ananya, when it didn't ask you to identify X, give the formula in terms of X only. Abhishek, same goes for you also. अरे magnesium के साथ form कर रहे हो. Yeah. So this will be, yes, most of you are getting it, MgX. And nitrogen के साथ. Nitrogen, let it be for now because it forms so many different compounds with nitrogen. We have nitrogen oxide, nitrogen dioxide, nitrous oxide, like काफी सारे. So let it be. Okay. So magnesium के साथ it's MgX. Ananya and Aditya Mundra, just be a little careful in how you write it. Magnesium में M capital G small and X is a different thing, like different element, different atom, right? So X should be capital only. Okay. All right. So these are the kind of questions that you'll get from periodic classification. Either it'll be purely theoretical, like Dobriner's triads, Mendeleev's law, Newland's law, like all of these, or definitions, atomic size, and all that. Or it will be completely this sort of a thing where you need to reason it out, like logical application based. Okay. All right, guys, any other questions, anything that you want me to discuss? Ma'am? Yeah, Nikki.
Yeah, I got a question in a paper. It said an element X, which is yellow solid at room temperature, shows catenation and allotropy. X forms two oxides, which are also formed during the thermal decomposition of ferrous sulfate crystal and other major air pollutants. Identify the X.
So you have X, it is yellow solid. और क्या दिया है? Shows catenation and allotropy. Okay.
Forms two oxides.
Two oxides. Okay.
Which are also formed during thermal decomposition of ferrous sulfate.
So decomposition of ferrous sulfate. This is an important clue. Okay. All right. What else is given about this?
And are major air pollutants.
Okay. These oxides are air pollutants. Okay. So just look at it. These are the hints given. Think about it. You guys tell me what it might be, and then we'll start the discussion. Abhishek, okay. Abhishek, like don't get hung up on only one like don't look at the first one, and like you need to take into account all 4 points. Same goes with you, Anirban. Like I know why you thought of that. Like obviously your brain goes to that because we literally just studied that. But also this is a very important hint. Like look at this and think logic. Elena got it. Yes. Aditya Rane got it. Good. See, you're given a lot of points. Obviously, I can understand your mind will pull you in different places. Yellow solid है, कुछ भी calcium हो सकता है, sodium हो सकता है, like lots of things are whitish, yellowish that way. Neki, yes, you got it. Next point is catenation allotropy. So, what do you know about catenation allotropy? The Anirban has a valid answer. He figured.
We know about carbon.
Carbon, yes. And secondly, catenation, especially catenation, यहाँ पे like it's there in the definition of this thing, right? Like it needs to be able to form long chains and all through covalent bonds. So I say you should know that it is absolutely a non-metal. So carbon हो सकता है, that's a valid thing. Which is why you come to the third point. Okay, Neil got it. Decomposition of ferrous sulfate. So if you, so ferrous, like, what do you guys remember about decomposition reaction?
Fe plus.
So decomposition matlab you take a single reactant. If you apply some sort of energy like thermal decomposition bola hai, okay, we are heating this compound and it gives some products. According to the question, two oxides
Okay, so sulfur dioxide and sulfur monoxide.
Sulfur trioxide. Okay, sulfur doesn't form monoxide. So, like carbon is a valid guess until you come to this point. So, ferrous sulfate को decompose करना है मतलब from this we are getting two gases. तो अगर इसमें carbon है ही नहीं, we have ion, sulfur and oxygen. तो क्या हो सकता है? Ion तो catenation allotrope में दिखेगा, हाँ. So oxides of some other compound matlab sulfur is our only valid this thing. So our two oxides are SO2 and SO3. Oxides of sulfur, oxides of nitrogen, they are major air pollutants. Sahi hai. So all that's left is sulfur is a bright yellow solid. You guys, I know it's been 2 years since you've like gone to school, seen the laboratory and all, but पहले sulfur को नहीं देखा है क्या? You guys didn't do the ion and sulfur का experiment? Mixing them, compound, like heating them without heating, with heating. No? Okay. So now that's valid. Like, okay, you don't know that it's a yellow solid. But sulfur is a very like bright yellow solid. And sulfur shows catenation and allotropy just like carbon. Even phosphorus has 4 allotropic forms. Like silicon shows catenation. So carbon is not unique. Definitely one of the biggest ones, but it's not like carbon is the only one that shows this thing. Sulfur also does it. Okay, so that is the reason I said, like, I know your brain will jump on, you know, it'll catch 1-2 words and you might think that, but look at it logically, like go through all the points and then figure it out.
And ma'am, the nature of these oxides is
acidic. And they're pollutants.
Yeah.
And
because metals form basic oxide.
Yes.
And sulfur is a non-metal.
Yes. In fact, your sulfuric acid is like if you dissolve sulfur trioxide in enough water, you get sulfuric acid. And if you take sulfur dioxide and dissolve it in water, you get sulfurous acid. But here you go. This is sulfur. These are like, it's a bright yellow color solid. That's what it looks like. And these are the two allotropes of sulfur. Like you have a crystalline form, like monoclinic and rhombic sulfur. That's what
And ma'am, there was another question as well. So first part of it stated a soft metal is stored under kerosene. Name and locate the following in the periodic table. But for this, there are two metals which can be stored in kerosene, right? Sodium and potassium.
Yes.
So which one should we state?
Both are valid. Is there any other information given?
No.
Okay. Kerosene. Go with either sodium, potassium. Both are valid. Both should be correct.
Okay. And the second part was an element with variable valency stored under water. So I did not get this one.
Okay. Element with variable valency. Okay. So whenever you come across variable valency, it's either a D block metal, like something like iron, copper, silver, etc., or it's a non-metal, like sulfur, phosphorus. All of these they have variable valencies. Now another clue is it is stored under water, right? So phosphorus is known for like it being stored underwater. Stored underwater means it's phosphorus.
So I didn't know about that variable valency was also there for phosphorus.
Yeah.
I thought about only Fa and C.
Right. So metals are one, even non-metals. So sulfur also shows like that is why you have two different oxides, right? Like SO2 and SO3. Variable valency hai idhar. Phosphorus also shows variable valency. Nitrogen has different valencies. Chlorine does not show. Chlorine also shows, like, although you don't know so much about it at this point of time, but most of the non-metals show variable valencies. But stored underwater is a sure thing that it is phosphorus. So do you guys remember, like, you guys learned about combustion, right? Do you remember spontaneous combustion? Yeah, no? Okay, but white phosphorus is very, very combustible. That if you soak a paper in white phosphorus and just like shake it around like this, it'll catch fire in the air. Phosphorus is known to be very, very combustible, very, very volatile, like very flammable, which is why, same reason why you store sodium under kerosene, you store phosphorus underwater so that it doesn't catch fire.
So phosphorus can be stored in water, but sodium and potassium can't be stored in water either.
Yeah, so sodium, potassium react with water themselves. Like that itself is gonna catch fire. Phosphorus, again, the danger is in air, in oxygen. As long as you prevent it from reacting with oxygen, it's fine. So store it underwater is perfectly fine. Water is commonly available and we'll keep it cold also. Will not catch fire. So store it underwater. Okay. Nice. These are good questions. Like this is how you get all of this information. The phosphorus is very, very uncommon. Like you guys haven't studied exclusively about phosphorus, so I'm surprised you have a question about that. But the sulfur one, yeah. Well,
actually, it was there in our prelim. So the main question was we have to name and locate the elements in the periodic table. So first thing we had to identify them. For the phosphorus thing, it was identification was difficult, and then we had to locate.
Both again, like once you identify, locating is pretty easy, no? Like now we figured it out based on the configuration. Yeah. All right. Cool. Anything else?
No.
Okay. And let me know if you want like another sample paper or if you want questions from a specific chapter or something like that. Let me know. Send it to you guys on the group. Yeah. Whatever you need.